Hi everyone. We want to share some of our newly acquired knowledge of the NoSQL Redis database. And for that, we are creating this tutorial that will cover basic things such as use cases, advantages, important features. We will also teach you how to install it, basic commands, among other things. Hope you can enjoy it. So let's start by defining what a NoSQL database is. So NoSQL is basically no and SQL, the combination of those two words. The implication is that NoSQL is a technology or product that counters SQL. NoSQL is not a single product or even a single technology. It represents a class of products and collections of diverse and sometimes related concepts about storage and manipulation. It was first coined by Carlos Strozzi in 1998 and then was later again reintroduced by Eric Evans in 2009. So basically NoSQL deals takes off some of the problems that relational databases have, such as not efficient processing, sparse data. In NoSQL, you can manage larger data, and also SQL is not scalable. Some of the greatest features about NoSQL is its scalability and productivity. It alleviates the problems that RDBMS imposes and makes it easy to work with large data sets such as Google. So basically, what is Redis? It stands for Remote Dictionary Server. And it is basically a high-performing single-thread server in the C programming language. It is key value data store, and it is completely in memory. So that's something that makes this NoSQL database very, very fast. Also, it gives you sets of data structures to use. You can basically use 6 data structures for manipulating data in Redis. Those data structures are binary strings, lists, sets, hashes, maps, hyperlog logs, etc. And one of the things that amazes people is how you can do transactions on it. And that's why it has been widely used in the retail and in the e-commerce industries, because basically you can do all types of transactions in seconds. And also it has APIs in C, Ruby, Java, JavaScript, and Python. So it will make any developer really happy. So as we were talking, some of its advantages is that it is very fast, and mostly it is because Redis is a cache, and a cache that has databases capabilities. So it combines the cache's advantages as well as databases advantages, and that is why it is so fast. Also, it is simple and versatile. It is because mostly it is reading it is used on the cloud, such as AWS, Google Cloud, and Azure. It is well documented, and you can actually go to Redis Lab, that are the company that supports Redis and are constantly improving it. And there are a lot of discussions and forums where you can see your problems, and you can even email or text or ask Redis Lab for help whenever you need so. As we were talking before, it supports 6 data structures, so developers can use them when using it, such as appending things to a string, incrementing the value in a hash, pushing an element to a list, computing sets, intersections, union, difference, getting the members with the highest ranking in a sorted set, among others. So basically, yes, it has rich data types. And as I was discussing, it can be used in the cloud. So some of the industries that use Redis are the financial services and e-commerce industries. As I was saying before, this is because it is very fast, and they provide these services to their clients. they can better be summarized into these four: fraud detection and mitigation, customer engagement and personalization, application caching, and session management. So basically, for the for fraud detection, they provide AI systems and analytics to be able to do so. And also, because of the application caching, as we were discussing before, it is so easy for them to do so. And also, well, the session management, it will better show, or well, it will better work with people logging in and storing their information, among others. Well, because it provides that capability. Then we have the retail industry. So Redis allows a proud catalog, order history, and cart searches, as well as ensuring data consistency and bilateral updates across channels, personalizations, promotions, and recommendations, and caching recent views. So basically, Redis powers searches through Redis Enterprise. So it lets customers quickly, accurately search through online catalogs, purchase history, and shopping carts without the need for applications to maintain and scale a massive global index of results. Also, in-store pickups and locations-based offerings require inventory data that's consistently updated across all channels. And well, as you can see here, I put some images from the Redis Lab showing how users will buy, and it will cache the recent views. It will also show the catalog, among others. It is also highly used in the healthcare industry. This is because Redis allows for delivery of healthcare applications with real-time performance. Also, it will apply AI to patients' data analytics and also their fraud detection capability, which we'll further discuss later in this tutorial. You can modernize claims processing and utilization management platforms. And lastly, because it will simplify cloud migration and IT modernization. So basically, some of the things that the healthcare industry loves about this is that they can apply artificial intelligence to patients' data. So it will basically help doctors and nurses better provide better services to a patient because of this, which I think is a great feature. Something else that Redis is really good at is for storing geospatial locations. So applications like Uber and Lyft use Redis to store their geospatial location, and also because it will also provide ease in the transactions, among others. That's why so many companies use it. And their deployment can be done in Kubernetes, first of all, which the Redis Enterprise Kubernetes Operator deployment is available across multiple Kubernetes platforms, such as Red Hat OpenShift, Google Kubernetes Engine, and also the VMware Tanzu Kubernetes Grid. It will also, you could also deploy using the VMware Tanzu application service, which is this logo here that you can see. And application developers can natively use the Redis Enterprise Service Broker for VMware. And lastly, which is what most people or companies do, is that they use the cloud. You can use Azure, Google Cloud, AWS to deploy Redis. So now I want to show you the Redis webpage. So the Redis Labs webpage, which are the ones who maintain and keep improving Redis. So basically, this is Redis Lab, and they have very good information here in their webpage. And I was explaining they have a whole session on the cloud and how their cloud partners Azure, Google, and AWS work. And also here in the overview, we can see that some of the advantages that they list for their product is that, well, for the enterprise, which are those who pay for Redis, is that they have a TCO, they have enhanced developer productivity, hybrid and multi-cloud, architectural simplicity and scale, among others. So one of the things that I was reading when I was researching more about Redis is that it is vastly used by companies who want to deploy their content or store their information in the cloud. So it serves for those hybrid companies that have some of their data on premises and also want some of their data in the cloud. So it's perfect for those companies. So yeah, some of the key features, as I was explaining, the true high availability, scalability, and I was explaining the hybrid multi-cloud on the globe. And also something else I wanted to discuss and show you here is the use cases of Redis. So they can basically summarize in caching, and I was saying session management, and that's why many companies use it for like retails and among others, because they will store people's information easily and fast. It also provides fraud detection, real-time inventory, claims processing, leaderboards. It will store messaging. It will also help with the notifications. It has fast data ingest and microservices. And here I was explaining, here are the 3 industries which are better discussed here in the Redis Labs webpage. So it's a webpage with a lot of resources. Also, I wanted to show you some of Redis partners, which are these ones. Microsoft, Google Cloud, Red Hat, and well, many others, Deloitte and Discover, Everest. It has like 3 pages of partners. And lastly, as you can see here, some of the case studies that Redis Lab has done. So companies that they have helped. So for instance, Matrimony.com, they're managing more than 3.5 million active users with Redis Enterprise. So as I was explaining, developers are amazed of how fast Redis will work. So, well, now let's go through the process of installation.
The next part of this will be about installing and how to install using Redis. First, you need to set up a Redis database. There are many ways to do it, and one of them is using Redis Cloud. We need to sign up for a free Redis Cloud account, and after that, you can just choose what kind of database that you want. Here is the create database page for free database with 30 megabytes size maximum. And here is your finished database configuration. Notice the database endpoint because that's how you're going to connect to it afterward. Here's some additional way for creating a database for different systems for Linux, Mac, and Windows. After that, you will start connecting your database using Redis command line interface. Notice that apart from using Redis Cloud, your Redis database will come reinstalled with Redis command line interface, and you can start using it right away. Here is how you're going to connect to your database. As mentioned before, you will need your endpoint of the database, which can be split into 2 parts, your host name and your post number. And you're going to use that to connect to your database. Note that you can connect to your database without a password, but you will not be able to modify anything of your database. And the last step is testing your connection to make sure everything working out okay through command. One dummy ping will return pong. Set full bar, we mean set bar at a value for full and return okay. Get full will return the full value with a bar that we already set it. For the next part, it's about basic command of Redis. Their web, the try.redis.io is an interactive tutorial which is very useful for starting to learn about it. Here are the 4 basic command of Redis. Set key value, we they set a value to a key. Get key will return the value of the key. Exist key is to test whether a key already exists or not. And delete key will just delete a key from existence. This is a value. This is a comment for working with counter value for credit. Increase key will increase the value by 1. Increase by will increase the value by a set number. And same with decrease and decrease by. Here's an example about the 4 command. Here you set when you increase the counter, it will increase by 1. And when you increase by 100, it will increase by 100. And the same for decrease and decrease by. And Redis also supports setting the time constraint on a key. When the time runs out, that key will be deleted. At the expire second is setting a time for a key. You can both set a value and a time at once. The command TTL key will return the remaining time for a key. A -1 means that the key doesn't have a time constraint. A -2 means that a key doesn't exist anymore. And persist key means remove the time constraint from a key. And here's the example about those 4 commands. When you set the timer to 120 seconds, you will see it start counting down. And when you use persist timer, it will remove the time constraint and the countdown time become -1. And when you delete the timer, the countdown time become -2. Redis also supports several complex data structure. And one important point for Redis is that you don't need to create a data structure and the data first before starting to work on them. You just start working on them through command. For example, when you want to add element 1 to set 1, if the element and the set doesn't exist yet, they will be created. And here are 3 data structure that Redis support. You have list, set, sorted set with a subset of sets, and hash. For list is a series of order value. You have push, pop, command like a stack. The right push and the left right push and right pop will interact with the end of the list. Right push will push the element to the end, and right pop will pop the end element out. And left push and left pop will interact with the beginning of the list. The length will return the length of the list, and the rank will return the element in a certain rank of the list. Here's an example when you see rank 0, 1, which means return the first 2 elements, and rank 0, -1 would return all the elements. The next data structure is a set. A set is similar to a list without the order of elements, and element may only appear once. You have add command, remove command. The S is member will test if an element is in the set or not, and the S member command will return all the elements. S union is the union between 2 sets and return all the elements from this. And F pop set can also use pop like list, but because set doesn't have an order of elements, it will remove a random number of elements from the set. A sorted set is similar to a set, but each element now have a score that can be used for sorting. For example, when you create a set and add this element into it, you can use Z rank to get an element from a certain rank. Z rank 1, 2 will return the 2 and the 3 elements from the list, from the set. The hash are mapped between string field and string value, so they are perfect for data type to represent objects. When you can set different element and value to an object. Like this, like you set user one, name, student ID, and major. And you can use hgetAll to return all the element and their value. Or you can use hget to return the value of one element from the object. And the next part is about Redis Insight, which is an intuitive and efficient UI for Redis. It's sort of like MySQL Workbench. It supports visualize and interact with the Redis database, built-in support for Redis module, memory analysis for Redis, trade Redis command, intuitive command line interface, and administer Redis.
So now let's talk a little bit about Redis modules. Just like Nan talked to us about Redis Insights, which is also a module. Redis modules are add-ons to Redis that extend Redis to cover most popular use cases in a wide variety of industries. They seamlessly plug into Redis and are processed in memory, and they provide Redis's simplicity, super high performance, scalability, and high availability. Modules can be created by anyone, and you adapt your database to your data rather than the other way around. And you can think of them as these Lego blocks right here, which fit on perfectly onto your database and improve functionality. We're going to be talking about 4 different Redis modules, which are Redis Search, Redis Gears, Redis Bloom, and Redis AI. So let's go ahead and talk about Redis Search a little bit. So Redis Search implements a search engine on top of Redis, but unlike other Redis search libraries, it does not use internal data structures, such as sorted sets. This enables more advanced features like exact phrase matching and numeric filtering for text queries that are not possible or efficient with traditional Redis search approaches. A demo of an implementation of Redis Search was shown that it indexed over 1 billion documents and 100,000 documents per second. And you can see a little bit about the indexing speeds here for different queries. And that is really impressive. Now let's talk about Redis Gears. Redis Gears is a serverless engine for transaction, batch, and event-driven data processing in Redis. It is a dynamic framework for the execution of functions that in return implement data flows in Redis while entirely abstracting the data's distribution and choice of deployment. These functions can be implemented in different languages such as Python or C API. Redis Gears supports the following operation, which are map, filter, group by, reduce, aggregate, sort, and for each. So it makes it really easy for the user to use these. Now let's talk about Redis Bloom. So Redis Bloom is another module that provides Redis with support for additional probabilistic data structures. These structures allow for constant memory space and extremely fast processing while still maintaining a low error rate. It helps us implement the Bloom filter. What is a Bloom filter? A Bloom filter is a probabilistic data structure which provides an efficient way to verify whether an entry is or is not certainly in a set. So if I have a large OnDis database and I want to know if a certain key exists on it, I can query the Bloom filter first, and it tells me with a certainty whether it potentially exists or not. And in this case, if it's not available, I can forego the expensive disk lookup and simply send up a negative reply of the stack. So as you can see, it is very cost efficient and it does not use as much memory. Redis AI is another module for executing deep learning or machine learning models and managing their data, decreasing latency, and increasing simplicity. It minimizes latency by retrieving the reference data directly from the database's shared memory. So as you can see here, Redis AI can implement different sorts of machine learning models such as PyTorch, TensorFlow, or Onyx. So how do you use these NoSQL technologies? So one of the industrial adoptions is a session cache. So many websites use Redis to create a session cache to speed up their website experience by caching HTML fragments or pages. Since this data is stored temporarily in the RAM, this attribute makes Redis a perfect choice as a session cache. It is able to temporarily store user-specific data, for instance, items stored in a shopping cart in an online store, which is crucial in that your users do not lose their data in the event they log out or lose connection. Because if that happens, you're losing customers. The other one is queues. So any application that deals with traffic congestion, messaging, data gathering, job management, or packet routing should consider Redis queues. So this can help you manage your queue size by the rate of arrival and departure for resource distribution. There are some sites that use usage and metered billing. You can use Redis strings as a real-time meter for consumption-based pricing models, such as Google Cloud or AWS, and it depends on how much you use. So in the telecommunications industry, where they may charge for text messages or minutes, this is your way to go. Social media platforms like Twitter also use Redis to populate their timelines and homepage feeds. And they can customize the top of the feeds with trending tweets or stories. So as you can see, we have a lot of uses for Redis, and the applications are endless. So what are some of the limitations? The first one is the cost. The whole data set always resides in RAM. So as you know, RAM is expensive. So the whole database can get really expensive. Memory fragmentation issues. Writing and deleting huge amounts of data can result in performance degradation, which is very disadvantageous if you're looking for fast queries or just fast access of data. You don't have access controls. So it's not possible to configure a Redis server or database that is serving, or any sort of key pattern as being read only to a subset of your clients. So you have to constantly be on the lookout and help clients with their access and problems that they might have. Transaction rollbacks. So once you do a transaction, you can't roll it back. There's no going back. So every transaction is permanent, and you have to be really careful about what you do with it. So moving on to security. Security is very necessary for a database to keep the data safe and secure. Redis uses all the well-known practices for writing source code to prevent buffer overflows, format bugs, or other memory corruption issues. So the Redis protocol has no concept of string escaping, and we learned about SQL injection. So it's impossible under normal circumstances to execute injection under normal circumstances using a normal client library. The protocol uses a prefixed length of strings and is completely binary safe. Redis implements the sort command using the qsort algorithm. So the qsort algorithm in Redis is not randomized, so it's possible to trigger a quadratic worst case behavior by carefully selecting the right set of inputs, and it can cause your database to crash. Another thing is the configure command. So the server configuration uses the config command, which makes the client able to change the working directory of the program and name of the dump file. So this can allow clients to write Redis files at random paths and potentially execute malicious code and gain entry to your systems.
Now let's see how to actually use Redis using Python and Java.
Okay, so Redis can also use in Python and Java. For Java, the Redis client library is Redis py. And to install it, we will use the command pip install Redis. And if we want to use the Redis in Python, we can import Redis in the Python code. And then here's an example of the Python code that using Redis. So here's the first line. We see that it is import Redis, and then we declare a variable R, which is Redis.Redis. Here's the host, which is the redislabs.com, and it will listen on the port 12345 and the password. Yeah, that's it. And then another one is the Redis with Java. With Redis with Java, the library for the Redis client is Redis, and Redis is a client library written in Java for Redis. To install it, you can download the Java source from GitHub, and then we can create a Maven project. So if we use Eclipse to write Java, you can create a Maven project in Eclipse, and then we can declare Redis in the Maven dependencies. Here's the code to declare it, and we have to know that if we want to use Redis, you have to have a Redis server running on the local host first, and then you will connect Java to the Redis server by using the code Redis equal new Redis localhost. If we have the Redis server running on the localhost, and this command will connect the Java to the Redis server.
The key, which is a string. So I will give it a try, like set my Jerry. Yeah, so the key value, the key is mice and the value is Jerry is already set, and we can check it by getting the key here. Okay, and we will set doc equals spike, so we can see if it is there here. Okay, and then we can also override the key by using the set command again. It's equal like Mickey. So now if we check the value of mice, it will be no longer Jerry but Mickey. Yeah, so we already override it, and then we will. And then we can also delete a key by using the del command. such as del mice. The integer 1 will show that we already delete one key, which is the mice. Now we will, now we can show the keys if the here. So we just only have the cat and the dog. We don't have the mice anymore because we deleted. And we can also delete all the key by the flush all command. Yeah, here. So right now, like all the key is delete. We can check it. Yeah, empty array. Every key has been deleted. So now we will create it again to use it. Okay, so right now we can have another command, which is the setex. The setex will create a key and with the value and also with the seconds. The second means that it will define like how long the key can exist. So if we create a key like so now, let me see, fished 10 seconds demo. Okay, so after 10 seconds the key will no longer exist. We can also use the setNX, which will avoid override. As we know before, if we use the set command on an existing key, it will override the previous value. But if we use the setNX, it will not override it. It will check if the key exists first, and if the key exists, it will not override it. So here is another Mimi. Yeah, you can see that right now the integer is 0, which means that it doesn't change anything. You can check it again by get cat. Yeah, it still be a Tom. Okay, so now we will move to the command for hashes. The first command for hashes is hmset. For this one, you need the name of the key, which is student, for example, and name John, age 15, major CS, for example. Okay, so the hashes, it will have many fields and many values, and it will link with a name and will create a hash. Okay, now, okay, so here we have we already have hashes, and we will try to get the value of it. Besides the name of the hashes, you also have to fill the name of the field. For example, I want to know the name of the student. Okay, so here's John. If you want to get all the key and all the, if you want to get all the field and all the value, you will use the command get all. Here, you can see like name John, age 15, major CS. And then another command you can use is hexist. This command will check for the exist of a field in a hash key. For example, if I want to check if the field name is in the student hashes, yeah, the integer here is 1, which means that the name field exists. But if we check for another field that does not exist, like hobby, student hobby, then this one, it will show the integer 0. Yeah, you can see that. And another command is hdel. For this command, you will use it to delete a field and the value of that field is a hash, such as I want to delete name. Okay, so it's already deleted. We will check it again by the get all command. Here, you can only see the edge and the measure. You will not see the name again. So now another command is the set annex. For this command, it will avoid override if the field hashes is already exist. So right now, if I want to override the field /h20, it will not allow it. You can check it again. The edge is still 15. Is our push. We already know that the list can have the head and the tail, and you can push an element to it from the left or from the right. So right now for our push command, it will push the element to the list from the left. Okay, so now we will set a list named num, and you will add element to it. Okay, so now we will have the range num 0, 1. This command will the L range num 0 -1 will show you the elements in the list num, and you see that the first element is 4, 3, 2, 1. Since we push the element to it from the left, so the first element we push to the list is 1, and then 2, and 3, and 4. So when you get the element of the list from the left, you will see 4 first, and then 3, and then 2, and then 1. So another command is lpop. If you use the lpop command, it will get the first element from the left, which is 4. Another command is rpush. If you want to push an element to the list from the right, then you use the rpush command, such as I want to push 0. Okay, so now if we see the list again, you will see 0 is on the bottom here. 3, 2, 1, 0. Another command is length. This one, it will print out the length of the list. Here is 4. Another command is index. If you want to get the index of if you want to get the value of an index in the list, then you use this command, such as I want to get the index of value 3. Then there will be 0. The idea here is the list in Redis, it will the first index will be 0. So here we have value 3 in the first position. So the index of 3 will be 0. And if you want to get the index of 2, it will be 1. So it is kind of like similar to what we have in array. And now of the index 0 to like 4. Okay, so now if we print out it again, you will see that it's no longer be 3, it will be 4. Okay, so now we will move to the command for set, which is another data structure in Redis. For the set, the first command is as add, which will create the set and add the members of the set. So such as I want to get a set called num and num1, and I will add 1, 2, 3, 4, 5, 6 to it. Okay, so now the set will have 6 members. Another thing you have to remember is for the set in Redis, there will be no duplicate of members. So you cannot have like 2 number 1
to number 2 or to number 3 in a set, all the members of the set have to be different. So now you will have them as members num1. So here you will see the number of the set in an order, and now you can also have another command which is as cut. This command will show you how many elements is in a set. So now I will create another set called num2. 4, 5, 6, 7, 8, 9. Okay, so now if you want to know which is the difference between set num1 and set num2. So if you want to know the difference between set num1 and set num2, here the difference between set num1 and set num2 will be 1, 2, 3. So if you want to store it into another set, which I mentioned before, you will use the command set diff store. Okay, so here the set num3 will have 1, 2, 3, which is the difference between the set num1 and set num2.
And the notation for sorted set in Redis is Z. Okay, so if you use Z add, it will create a sorted set for you. So the way a set is sorted in Redis is by the score. So each member in the sorted set will have a score, and the bigger the score, you will arrange the members of the set by the score of it. Such as like a member with score 1 will be first, and then the member with score 2. I will make an example here. Num sorted num. So here we have a sorted set called sorted num, and I will add 1 A, 1 B, 2 B, 3 C, 5 D. Here. Okay, so now the sorted set called sorted num will have 4 members.
The members of the set, you will use set range, name of the set, which is sorted num, and the start and the stop integers. It is similar to what we have in list and set. So we will use the number 0 and -1 if you want to print out all the members of the sorted set. Here you have A, B, C, D. Another command is zcount. So for zcount, it will print out the members of the set with a mean score and the max score. So if I want to print out the members of the set with the mean score is 1 and the max score is 3, it will show that it will be 3 members, which is A, B, C. Another command is sram, and as we know before, ram means remove. So this one, it will remove the members of the sorted set. Such as B. Okay, so now the B is removed. You can check it again by that range here. We only have A, C, and D. So now if you want to, another command is that rank. So for this command, it will show the rank of a member in the sorted set, such as C. The rank of C is 1. Z ref rank sorted num D. Okay, so the zref rank command is the rank of the sorted list but in reverse order, which means that it will reverse the sorted set and it will print out the rank. So if we reverse the set we have here, the first element, the first member now will be D, and then C, and then A. So D will be at index 0, and if we check for A, it will be at index 2. Yeah, I hope you understand it. And then the next is Z-score. The Z-score will show you the score of a member in the sorted set. So if we ask for sorted set num, if we want to show the score of member A, the score it will be 1. If we want to get the score of member C, it will be 3. Okay, so that's it for the command for Redis, and I hope you enjoy it, since I think the command in Redis is pretty straightforward. So hope you can use Redis in the future. Thank you.